Alright, today's lesson is going to be on factor change. Factor change questions will be like this. An equation like the one that we learned yesterday is given to you, and it's going to ask you things like, what would happen to the force if mass gets bigger? Which you might already know the answer, but it's also going to ask you, what would happen to the force if mass becomes 2 times bigger? Also, it'll ask you things like, what would happen to the force if distance becomes 2 times bigger? We need to answer those questions. So we're going to learn about factor change by exploring some simpler equations. Notice that this equation is really complicated. But for example, if it asks you, what will happen to force if mass gets bigger? All you need to look at is the force and the mass part of the equation. If it asks you, what will happen to the force if distance gets bigger? All you have to look at is the distance portion of the equation. You can just imagine everything else doesn't exist. So, we're going to look at some pretty simple equations to figure out the factor change. So let's start off with this equation, y equals to x. We're going to fill in what happens to y when x is 1, 2, 3, 4, and 5. Well, since y is equal to x, y is equal to whatever x is equal to. So as you can see, what happens to y when x gets bigger? Well, when x gets bigger, y gets bigger as well. Specifically, what happens when x becomes 2 times bigger? Like you can see here, when it goes from 2 to 4, x is getting 2 times bigger. What happens to y? Well, y also goes from 2 to 4, so it is also getting 2 times bigger. So we know that when two variables are on the same level, like x equals to y, they are directly proportional to each other, meaning one goes up, the other will also go up. But more specifically, if there are no squares on either side, such as mass and force, there are no squares here and they're on the same level. Specifically, when one side gets 2 times bigger, the other side will also get 2 times bigger. Just like this equation. When one gets bigger by 2, the other will also get bigger by 2. Now we're going to take a look at what happens when they're on different levels. And maybe you already know the answer. We're going to take y equals to 1 over x. And we're going to see what happens to y as x is 1, 2, 3, 4, and 5. Well, since y is 1 over whatever x is, when x is 1, y is just 1 over 1. When x is 2, y is 1 over 2. When x is 3, y is 1 over 3. When x is 4, y is 1 over 4. And finally, 1 over 5. Okay? So, what happens as x gets bigger to y? Well, when x gets bigger from 1 to 2 to 3 to 4 to 5, y is actually becoming a smaller and smaller fraction. So we can see that as x gets bigger, y gets smaller. Specifically, when x is 2 times bigger, times 2, what happens to y? Y goes from 1/2 to 1/4. It's not multiplying by 2, it's dividing by 2. So it's actually getting 2 times smaller. So if we look at the original question, when distance becomes 2 times bigger, what will happen to force? Well, maybe you think that when distance is 2 times bigger, force will be 2 times smaller. That might make sense. But it turns out that this square here actually makes a difference. We're going to now look at what happens when we have squared proportions. We're going to start with a simple equation, y equals to x squared. We're going to see what happens to y as x becomes bigger from 1 to 2 to 3 to 4 to 5. What happens to y? Well, y is whatever x is squared. So when x is 1, y is 1 squared. When x is 2, y is 2 squared. And then it's 3 squared, then it's 4 squared, then it's 5 squared. This looks a little bit different than earlier when y is just equal to x. We're going to look deeper into this. But first, what happens to y when x gets bigger? You can see that when x gets bigger, y is also getting bigger. It's going from 1 to 4 to 9 to 16 to 25. So again, y gets bigger. And this shouldn't be too surprising, as you can see x squared and y are still on the same level. So when one gets bigger, the other one also gets bigger. But it asks, specifically, what happens as x gets twice as big? Let's write that down. X gets 2 times as big. What will happen to y? Y gets how many times bigger or how many times smaller? Well, first of all, we already know that it's going to get bigger, so we know that it's going to get some time bigger. Now, let's choose when x goes from 2 to 4, it's getting 2 times bigger, which is what we want. Let's take a look at what y goes through. Y goes from 4 to 16. Well, going from 4 to 16, how do we get from 4 to 16? Well, we multiply by 4. So when we multiply 2 to x, we multiply 4 to y. And when we say multiply by 4, another way to say it is multiplying by 2 squared. So in other words, when we multiply x by 2, we actually have to multiply y by 2 squared. When x gets 2 times bigger, y gets 2 squared times bigger. And that shouldn't be too surprising, right? Because there's a square next to the x, so when x gets bigger, y gets that many times squared bigger. What happens when x gets 3 times bigger? Well then, y gets, let's see. Let's go from 1 to 3 for x. I know that's multiplying by 3. What's happening on the y side? Well, y goes from 1 to 9. Well, from 1 to 9, I know I'm multiplying by 9. So when x gets 3 times bigger, y gets 9 times bigger. But another way to say that is that y will get 3 squared times bigger. So it might make sense if we look at the original question. What happens when d gets 2 times bigger? What will happen to the f? It might start to make sense to you now that when d is 2 times bigger, that f will be 2 squared times smaller. Now we're going to see if that's true by actually plugging in some numbers. We're going to look at this equation, y equals to 1 over x squared. And we're going to see the relationship between x and y. 1, 2, 3, 4. Okay? When x is 1, y is 1 over 1 squared, which is 1. When x is 2, y is 1 over x squared, which is 1 over 2 squared, which is 1 over 4. When x is 3, y is 1 over 3 squared, which is 1 over 9. Then it's going to be 1 over 16. What happens to y when x got bigger? Well, when x went from 1 to 2 to 3 to 4 and got bigger, y became a smaller and smaller fraction. So you can see y gets smaller. And it makes sense because if you look at this equation, the x squared and the y are on opposite floors. One is upstairs and one is downstairs. They're inversely proportional. But more specifically, what happens when x gets twice as big? We're going to go again from 2 to 4. That's twice as big. What happened to the y? Well, it went from 1/4 to 1/16. What happened from 1/4 to 1/16? Well, I know we actually divided by 4, which is the same thing as saying divided by 2 squared, right? So when x gets 2 times bigger, in this case, in this equation, y gets 2 squared times smaller, right? When x is bigger, y is smaller because these are inversely proportional. When x gets 2 times bigger, y gets 2 squared times smaller because the x is squared. What happens when x gets 3 times bigger? Well, when x goes from 1 to 3, it gets 3 times bigger, and y goes from 1 to 1 over 9, and I know I divided by 9, which is dividing by 3 squared. So when x is 3 times bigger, y will become 3 squared times smaller. And that is it. We will use those ideas to do our practice problems for factor change. And all you have to figure out in here is what is happening to the mass or what is happening to the distance. For example, in number 1, it says that a supervillain blows away half of the moon's mass. So if half of it is blown away, then that means your mass has gotten smaller. What will happen to the force if your mass gets smaller by 2? And then the next question asks, what will happen to the force if the distance is twice as big? 2r, 2 times as big as the original distance. What will happen to force if distance is 2 times bigger? Remember, distance is squared. And then for number 3, it just asks, what happens when distance is 3 times bigger? Good luck with the practice problems. Raise your hand if you have any questions.